Hello. So now we're going to do this example. So last week, David's car lot had 140 cars. If the inventory had declined by 25% this week, how many cars are there on the lot now? Okay. So now, just reading the question, we can see that we have a value for last week, 140. We can have a percent decline of 25%, and we're asking how many are on the lot now. Since that was the value last week, that'll be our before value. Our after value will be the value we're missing, and our percent decrease is 25%. Okay, so let's list that down first, list what we have. Then we're going to proceed to systematically solve the problem. So as mentioned, our before was last week. That was 140. So we're going to put 140 here. Now, what we don't know is how many are this week. So since we don't know that value, we're going to put an A here, okay, to represent the number of vehicles that we have, that David's car lot has this week. And then the X is we're gonna have to incorporate X. The X is the 25% decrease. Now remember, we recall that if X is less than 0 in the case of a percent decrease, okay? If X is less than 0, corresponding to a percent decrease, comma, then 100 minus X if X is less than 100, I'm sorry about that. If X is less than 100, corresponding to a percent decrease, then 100 minus X is the value of that percent decrease, okay? Okay. So in our situation, we know that it's a 25% decrease, right? So that means that this will have to equal 25. So 100 minus X equals 25. Okay. And that's going to allow us to solve for the X. Okay. So what we're going to do here is we're going to add the X to the other side so that we don't have to have it negative. And we're going to subtract the 25 to the other side like this. Okay. Okay. So 100 minus 25. We're going to do that here on the side. Okay. 100 minus 25. The way this is going to work out is, I want to ask, can I take away from 0? No. Can I borrow from this 0? No. So what I'm going to do is I'm going to borrow 100. This is going to become 0. I'm going to make this into a 90, and I'm going to make this into a 10. Because 90 plus 10 is 100. Okay? 10 minus 5 is 5. 9 minus 2 is 7. So I can see that this is 75. When I added the X here, this went away. When I subtracted the 25, this went away. And I'm left with 75 equals X. Oops. Like this. Okay? So that is 75. Now we have the three things we need in order to set up our standard proportion that deals with the percentage increase and decrease problems. Okay? Okay, let's continue there. So as you recall, this is our standard proportion for dealing with percent increases and decreases. Okay? We have our values here. Let's plug them in together. Our after value is A, so I'm going to put A on top. Our before value is 140. Our X we found was 75. And of course, there's 100. Okay. Now we recall whenever we're dealing with these kind of problems that if A over B is equal to C over D, then A times D is equal to B times C, which is what we've written here. I want you guys to sear this in your brain. Okay. So now looking at this, A times D is 100A, and that's equal to 75 times 140. So now, what I'm going to do is I'm going to carry out this multiplication over here. So 75 times 140. Okay. 5 times 0 is 0. 5 times 4, that's 20. I bring down my 0, carry my 2. 5 times 1, that's 5. 6, 7. When I add the 2. 7 times 0 is 0. 7 times 4 is 28. I'm going to bring down the 8, carry the 2. 7 times 1 is 7, plus 2 is 9. Okay? So I get 0, 0, 7 plus 8, that's 15. I carry the 1. 1 plus 9 is 10. Okay? So now I can see that 100A is equal to 10,500. Okay? Okay. So therefore, to get the A by itself, I'm going to divide the left-hand side by 100, and I'm going to divide the right-hand side by 100. Okay? Okay. This is gone, and we get A equals 10,500 divided by 100. Okay? Okay. So let's look at that together. Okay. So we know that when we're going to do division like this, the denominator goes on the outside of the house and the numerator goes on the inside of the house. So it'll be 100 on the outside of the house and 10,500 on the inside of the house. And also, let me make my multiplication table here. Now 100 is easy to multiply, and so I'm just going to write it down here. But if you do it on your own by adding over and over again, you'll see that this is exactly right, the way I'm going to write it in here. Okay. So I ask myself, does 100 go into 1? No. Does 100 go into 10? No. Does 100 go into 105? Yes. Looking at our table, we can see it goes in 1 time. And then 1 times 100 is 100. So I write that here. And I perform the subtraction. 5 minus 0 is 5. 0 minus 0 is 0. 1 minus 1 is 0. And then I drop down this 0. Notice I did the subtraction, I dropped down 1 digit. Then I ask, does 100 go into 50? It doesn't. Okay. So I put a 0 there. Now observe, had I dropped down 2 digits, I would have asked the incorrect question. Does 100 go into 500? And I would have put a 5 there, which would have been wrong. By dropping down 1 digit and asking does 100 go into 50, I was able to arrive at the correct answer, which is that it goes in 0 times. Now 0 times 100 is 0. And then I subtract 0 minus 0 is 0. 5 minus 0 is 5. Then I bring down this digit. And I can ask the question, does 100 go into 500? It does 5 times. 5 times 100 is 500. I subtract these and I get 0. There's no further digits to drop. And so that's when the division stops. So this is 105. Okay. And so now we are prepared to state the solution to this problem. Okay, let's do that together. In fact, we can observe that there are 105 cars on the lot now. I hope you'll enjoy this problem, and I'll see you again soon. Thank you.